Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue thinking about sedimentary environments and sedimentary rocks. So in this video we're going to think about fine-grained clastic sedimentary rocks, a group which is commonly referred to as the mudstones. And these contain rocks which are composed predominantly of silt and clay-sized clasts. So this video is going to correspond to section 7.10 of your textbook. So when it comes to the mudstones, there are three main groups of mudstones. That's the siltstones, the mudstones, and the shales. So how do we split up rocks into one of these three groups? Well, if your mudstone consists of greater than 2/3 silt size class, you are going to classify it as a siltstone. If your rock consists of greater than 2/3 clay size clasts, you are going to classify it as a shale. And if it falls somewhere in between those two end members, you are going to classify it as a mudstone. So it's a relatively simple classification scheme based on the percentage of silt and clay size class in your rock. Now, in terms of the environments where we tend to find these fine-grained sedimentary rocks forming, the key control is that they have to be very low energy environments. And that's because it's actually quite difficult to get silt and clay-sized particles to fall out of suspension. The reason is that they are very, very light, and so a very gentle breeze or water, even if it's moving ever so slightly, still has the capacity to move these very fine clasts. So you need your water or your wind to be nearly completely stationary. So you need a very, very low energy environment, and that allows these fine particles to slowly rain out and form a layer on the bottom of your floodplain or your lake or wherever. So the common environments in which we expect to find these muddy sediments forming on land are environments where we have this fine-grained sediment being brought in by the wind. So in desert environments, we obviously have sediment that's being moved about by the wind. Now, obviously the bigger size class, the boulders, the cobbles, the gravels, they can't be moved by the wind, so they don't really bother us. The sand can be blown about by the wind, but it can't really be picked up and moved by it. It's just rolled along the ground. Silt and clay-sized particles, on the other hand, can be picked up by the wind, and they will be transported in some cases for quite large distances. So, for instance, every once in a while we will get Saharan dust being deposited across the southern states of the US. And so obviously this Saharan dust has been picked up by winds, it's been transported all the way across the Atlantic, and it's being deposited into the southern states. And so that shows you, that gives you a hint of some of the distances that can be covered by this stuff. So if you happen to be in an environment where you have lots of this wind-blown clay and silt-sized material being deposited, it can slowly build up over time and in some cases form reasonably large deposits of clay and silt-sized material. Now, arguably the most common environment in which we find muds forming on the land is floodplains. And so obviously the floodplain is the flat area either side of a river, typically a meandering river. And the mud, or should I say the clay and the silt, comes from the river flooding. So we can see in this picture here that we have the river water right here, and you'll notice it has a murky brown colour to it. And this is because you have lots of silt and clay being held in suspension in the river water. So obviously when there's a flood and the water leaves the river spreads out over the surrounding area, and as it spreads out it starts to lose velocity, and eventually the water will get slower and slower and slower, and eventually it will come to a complete standstill. And at this point, that is when the silt and clay sized particles can begin to rain out of suspension and settle onto the floodplain. The other continental environment or land-based environment in which we would expect to find mudstones forming in large quantities is in lakes. So along the edge of the lake we know it's going to be an active environment because we know the wind is going to be blowing the water and producing waves. However, in the middle of our lake in deeper water we know the water is going to be very, very still and very, very stable. And so once again we have a situation where we're going to have water entering our lake, mostly from rivers. That water is going to contain clay and silt sized class, and so as that water enters the lake it will eventually work its way towards the lake centre. The water will slow down, stop, and it will slowly allow the silt and clay to rain out into the bottom of the lake. So what about the accumulation of clay and silt size class along shorelines and offshore? Well, along the coast, we know that the environment tends to be dominated by sands. And this is because sediment that gets deposited on the sands obviously gets deposited on the coast, gets reworked by waves. And so what happens is when a wave hits a beach, it obviously rolls the sand up the beach and it rolls the sand down the beach. Now, if there's any finer particles there, like silts and clays, the wave actually picks them up and it takes them and transports them back out into open water because they're so light. And so this means over time, fine particles like silt and clay get removed from beach deposits and they get transported into deeper water. And this means that the sediment along the coast becomes sand dominated. Now, there are some areas of the coast though where we do have muds building up. These areas are typically associated with rivers, and so these rivers are coming to the coast and they are depositing their sediment as they hit the coastline. And obviously these rivers are going to be transporting quite large amounts of mud. What happens is because of the action of tides, it causes this mud to be redistributed and spread out. And so we don't end up forming a delta. Instead, what we end up forming is a flat area of muddy sediment along the coastline, which we refer to as a mudflat, and you can see one right here. And so most of this sediment is going to consist of clay and silt size class with lesser amounts of sand mixed in. And typically these mudflats will form in relatively protected environments, so bays are a good example of an environment in which we would expect to find these mudflats forming. And mudflats will typically spend half their day underwater during high tide, and they'll spend the other half of the day exposed to the atmosphere during low tide. So the next coastal environment in which we would expect to find muds being deposited is in a lagoon environment. So a lagoon essentially is a protected body of water, and it's protected because in front of the lagoon there is some kind of barrier, and this barrier could be a reef or it could be a barrier island. Either way, the presence of this barrier helps to essentially break up waves coming into the lagoon area, and this means the water in the lagoon tends to be rather protected and rather still. And so this means that if you have water which contains muddy sediment entering the lagoon itself, the water will be allowed to slow down, come to a near complete stop, and the clay and silt sized particles will be deposited in the lagoon. The great thing is about a lagoon is because it has this barrier, it actually stops the waves redistributing this muddy sediment and pulling it out into deeper water. And so this means your lagoon will slowly fill up over time with muddy sediment. And this process is actually called silting up because the lagoon is literally filling up with silt. So the final environment in which we tend to find muds forming in large quantities is in the deep ocean environments. So these are environments which are typically past the continental shelf, past the continental slope, and we're into the deep sea, the really, really deep water. So in these environments, the water is very, very still. And so this means that any clay or silt-sized particles that make it out that far into the deeper water, well, the water slowly slows down, it decelerates, it comes to a complete stop, and then the clay and silt can rain out very slowly onto the seafloor. And the rate of deposition of muddy sediments in these deep marine environments is extremely slow. So, you'd be looking at accumulation rates of somewhere in the region of about 1 to 5 millimeters every 1,000 years. So it's a very, very slow rate of sediment buildup in these deep environments. Anyway, thank you for watching the presentation, everybody, and have a good day.